Yes.
Everyone hear me? All right, what's up, guys? My name's Hunter Rocknich, and these are my colleagues, Andy Rolfus, Mohammed Al-Badi, and Fahad Al-Saber. And I know you guys have been sitting for 3 hours now listening to everyone's presentation, so we'll try and keep it at least monotonous as possible, even though this will be the fourth time you've heard about thermal injection. So, as we said, we based our research on the process of thermal injection, and it's a highly used process in enhanced oil recovery. You can see from different companies, some say that about 40% of enhanced oil recovery is thermal injection worldwide. I know Dalil, they're based out of the Middle East, and they said that it goes all the way up to about 60% worldwide. But there are multiple parameters that we have to look at and analyze in order to determine if thermal injection is the right thing to use. And some of those would be things looking at, is it a heavy oil? Is it have a high viscosity? So we'll go into that for our process. And then we'll look at 2 case studies. And those case studies are good to look at because it shows actual research. It gives real life applications to see why it's a good thing to use thermal injection and why it's important for enhanced oil recovery. And then finally, we'll discuss the viability of thermal injection. Is it good to use it? Is it economic? We need to see what the best time to use it is. And it's important because as petroleum engineers, we are responsible for a lot of money. We take care of a lot of money. And it's our job to make sure we are using it as most effectively as possible. And if it's not viable, then we need to look into other forms or consider abandoning it. So with that being said, I'll now pass it on to Fahad and Mohammed, and they're going to discuss the process.
Okay. Thank you, Hunter. The thermal injection process is a standard method used in the recovery of crude oil from the extraction sites.
And the thermal injection process entirely relies on the principle of matter expands when heated due to the increase on the kinetic energy of the heated state of matter.
It occurs in different forms, such as cyclic steam injection, steam drive, steam-assisted gravity drainage, and fire flood, or in situ combustion.
And especially in this method, the oil reservoir are stimulated using steam to initiate heat energy on the oil deposits in the ground. The technique reduces the viscosity of the crude oil by the use of heat from the steam injected, which eventually eases the flow of the oil toward the collecting well for extraction.
The technique is used in California, the USA, Alberta, Canada, Lake Maracaibo, Venezuela, and Oman.
And the cycle steam injection techniques involve the shooting of the steam into the well and in pits and eventually lift for a given period of time for oil to flow out naturally. It can only extract not more than 20% of the total oil available at the place of mining.
The steam flood, also called steam drive, entails steam injected into the reservoir passing through the injection well. Oil recovery of about 25 to 75% of the oil in the place is obtained during the extraction by means of the steam flood technique.
And the SAGD use pressurized steam that propagated through an upper well, forcing the heavier oil to drain into the lower well, where it's then collected at the surface. Fire flood techniques, also called in-situ combustion, method directly generate heat in the reservoir using the burns and the presence of oxygen concentration.
The in situ combustion approach brings forth a recovery rate about 35 to 40% of the total oil available in the oil field. The method used in oil recovery should consider factors such as the weather patterns, availability of natural gas, and cost incurred in a bid to avoid any inconvenience during the extraction.
And now my partner Andy will discuss about the cases studies.
Okay, we looked at 2 case studies. Our first one was the Sai Reservoir, and this is located in China. It's one of China's biggest oil fields. It's in the Daking oil field. It's a heterogeneous formation, much like every formation in the world. Consists of sandstones, siltstones, and shales with low permeability. Their original form of EOR for this reservoir was water flooding, but then they decided to run some tests with steam flooding in 2005. So steam flooding on the Sai Reservoir, you have a higher injection rate compared to water flooding. It's you can inject gas faster than you can inject water, and their tests showed that the producers showed 3 times more production than in water flooding, and you have a lower water cut, which means production of more oil. Production 1, water produced over oil produced gives you your water cut. Here's a graphic to show your green/yellow/lime color here shows your water cut and how low it is. Your red is your oil produced, and the purple magenta color is your total liquid. So obviously you're producing a pretty high percentage of oil compared to your total liquid. So here's your case study number 1 results. So your steam flooding is most effective on heavy reservoirs, heavy oil reservoirs, which makes sense. Those heavy oil reservoirs, you get in, the steam lowers the viscosity, so it's easier to flow. But then again, you can't use steam flooding on every reservoir. You have to have the right match to maximize the efficiency. And the steam flooding on this reservoir was so successful that the field engineers were calling for the technique on a larger scale in the field. Now our second case study was in Kazakhstan. I'm not going to try to pronounce that because I don't know how. But so this was an interesting one because it looked at the effects of wet steam versus superheated steam. Wet steam is a same concept as wet gas. It's a combination of liquid water and steam. Superheated steam, everyone took thermo. It's not in the house, if you remember from Paul Daniel. It's very, very hot. So they used the CSS, which is a cyclic steam stimulation, which you've heard plenty about tonight, with wet steam. But they decided to run the superheated steam in the lab before they took it to the field. And they wanted to observe the relative permeability of water and oil, connate water saturation, and residual oil saturation. So here is a couple of the results. So superheated steam, a cool thing about it is it had the ability to change the wettability from oil wet to water wet. You obviously want your formation to be water wet so that you can flow oil out. It increases the water mobility. At the same pressure, this is kind of a simple Pivnert concept here. At the same pressure, superheated steam occupied 2.5 times more volume. So for the same, so you're getting kind of more bang for your buck, even though it is more expensive to superheat it to that temperature. They saw a 60% increase in production compared to the wet steam, which is pretty significant. But then again, like I said, it's a lot more expensive. So I'll turn it back to Fahad and Mohammed to talk about the viability.
Thank you, Andy. And for the viability, as you know, the EOR is considered as one of the most critical processes employed in the production of the oil. EOR describes a process in which oil reservoirs are exposed to extreme temperature to reduce viscosity and reduce and recover of fuels.
Moreover, there exists a wide range of injection methods used to recover oil, which includes hydrocarbons, steam, and carbon dioxide injection, which account for 15%, 24%, and 56% of the total oil recovered respectively.
And the increase depends on oil as the main source of energy, has spared significant focus on thermal EOR methods as critical ways of recovering oil.
It is noteworthy that the process in question has a huge potential of recovering of more components from the subsurface at a relatively lower economic investment compared to conventional approaches.
And most of EOR processes, such as steam injection, do not cause any threat to the environment because steam comprises water, which is environmentally friendly.
Moreover, there are 2 primary types of steam injection mechanism, which include cyclic stimulation and steam flooding.
and the methods are used interchangeably depending on the amount of oil intended to recover and the amount of financial investment to be invested in the process. However, steam injection methods have been found to cause significant harm to the well structure, which threatens the life of individual working in the process.
Based on the explained ideas, it is clear that most fields across the globe depends on thermal AUR to increase the level of hydrocarbon production. It is worth to note that the viability of the method in question is enhanced through 45 seismic waves surveys, which are means to obtain the reaction of any particular change in sources.
Such modification, pressure, temperature, and flow saturation. On the other hand, the ideal conditions for thermal AUR process to occur requires increased mobility and reduced viscosity.
Specifically, this is because a decrease in viscosity increases oil permeability and reduced surface tension, which improves the seepage condition of the source.
Further, mobility enables oil to flow via the source and create high-quality oil after being exposed to a series of concentration process. It's worth noting that while the steam injection is the most preferred method due to its environmentally friendly nature compared to other ways, the fundamental deciding aspect is cost, which determines whether a specific method can be used or not.
Thermal oil recovery methods are usually embraced in heavy oil sources that have reduced mobility and high viscosity, so that the introduction of steam offers better passage for the smooth flow of the recovered oil.
Although steam injection is considered expensive, proper heat management and design may retain significant economic success. Moreover, with the increased utilization of thermal AUR on large-scale production in Oman, China, North America, Indonesia, and some parts of Brazil.
Overall, the prospects for success for the process in question seems sustainable and economical, which explain why it will continue to dominate oil recovery.
So today, thermal injection is being used worldwide, but it's not necessarily a new concept, but it's something that we're starting to use more commonly now. And with the way technology is progressing, this process will only continue to be used more. We're going to learn new ways to better it. And also, we're in need of utilizing this for reservoirs that we haven't been able to use in the past. So some reservoirs that we have already produced, we can now go back to and possibly produce more. It's a very good way for us to maximize our production. But on the other hand, it can be expensive. So that's something that we have to look at. But if the return on investment is worth it, then that's something that we should do. But we are always looking to progress in the industry. There's always going to be new ways that we find. We're engineers, that's what we do. New ways of trying to be more economical. Like Caleb said before, we also looked at the use of solar panels to try and cut down costs and see if that's something that's worthy to do. But with that being said, is there any questions?